Thus, P of X is equal to 3x squared minus 2x minus 6 has a 0 between 1 and minus 2. If I calculate P of 1 and then also calculate P of 2, if you recall, we had a theorems, intermediate value theorems, means if P of A and P of B are opposite of each other, it means the graph going to intercept at some point on x-axis. So if I evaluate P of 1 and P of 2 and that turns out to be opposite numbers, then the answer would be yes. There's going to be a 0 in between those two values. In other words, your graph going to pass through 0 between those 2 points. So that's all you really need to do is evaluate P of 1, substitute for each x1. Then here you would get 3 minus 2 minus 6. 3 minus 2, I give you 1. 1 minus 6, minus 5. So I get a negative number here. If I evaluate P of 2, if I substitute for each x2, if I get a positive number, the answer would be yes. So here I get 3 times 4 minus 4 minus 6. 12 minus 4 minus 6. Yeah, so you get 12 minus 10. So I get 2. So P of 1 is equal to negative 5. P of 2 is equal to plus 2. So there is a change of sign there. So the answer is yes. And then your explanation, you can write intermediate value theorems. We looked at that before. So for this problem here, you could find the vertex. If you want to graph this by hand, you want to see what's the lowest point of the graph is, or you could use your calculator to graph this and look at where does it increasing or decreasing. But if I want to do it by hand, I need to find the x location of the vertex. You recall anyone how to find x location of vertex by looking at the polynomial? This is something that you definitely want to remember. V of x is equal to, anybody remember that?
Negative v over 2a.
Very good, negative v over 2a. Make sure we remember that. X position of the vertex is negative v over 2a. So in your case, your a is equal to 3. Your b is equal to minus 2. And your c is equal to minus 6. So we get minus, your b is minus 2, divided by 2 times 3. So I get 2 over, I could reduce this, 2 over 6. And I give you plus 1/3. Okay, so v of x, x position of the vertex is 1/3. To find the y position of the vertex, what do we do? Plug it in. So you get, you substitute for each x 1/3. in your polynomial. Okay. So you substitute there, you get 3 times, or 3 over 1 times 1 over 9 minus 2 over 1 times 1/3 minus 6 over 1. You can reduce this to 1/3 minus 2/3 minus 6 over 1. The LCD is 3. I need to multiply this last one by 3 over 3. So it looks like you get 1 minus 2 minus 18 over 3. So that would give you minus 19 over 3. So if I'm going to graph this, roughly, this would be a parabola that opens upward or downward. I hear down, upward or downward. If A is positive, means your graph, your parabola opens upward, right? If A is negative, that means your parabola opens downward. So your parabola should open upward. And I know that vertex, the vertex would be 1/3. So somewhere around here, if x equal to 1/3, y is equal to minus 19 over 3. Okay. So that would be about 6.3. So if you come down to about 6.3, somewhere around here. So this would be my lowest point. You can actually find your x and y intercept if you like, but the rough graph would be somewhat like that. So the questions on the other part, the lowest point then would be your vertex right here. Given the interval of increasing, the function increasing from this point here all the way to infinity. For increasing then would be, I'm going to use brackets, 1/3 all the way to infinity. This is where your function increases. Increases from 1/3 to infinity. Increase. Decreasing would be from negative infinity all the way to that point of vertex, which is 1/3. So there is no maximum here, but there's a minimum. The minimum value is your vertex. That would be your minimum value. Give all values of k that ensure exactly one real solution for this polynomial. In order to get one real solution, you discriminate, which is b squared minus 4ac must be equal to 0. So let's find what b is. Well, let's find what a. Your a in this case is k. That's the coefficient of x squared. Your b is coefficient of x, which is 16. and your C is K. Let's substitute those values there in this discriminant. B squared would be 16 squared minus 4 times your A is K, and your C also is equal to K, equal to 0. So you get 256 minus 4K squared equal to 0. To solve for K, get 256 is equal to 4K squared. Divide both sides by 4. You get K squared is equal to 64. So K must be equal to plus and minus square root of 64. K must be equal to plus and minus 8. So if K is equal to plus or minus 8, then we get one real solution, because that results into B squared minus 4AC equal to 0. It's given g of x equal to 2x to the power of 2 minus 2x minus 24. Express the quadratic function in its standard form. To do that, we need to complete the square. G of x is equal to 2x squared minus 2x minus 24. We want to make this look like this standard form. To complete the square, we would separate the x from the constant. We want to make sure that the coefficient of x squared is equal to 1. In this case it's 2, so I'm going to factor the 2 out among these two terms. I get 2 times x squared minus x. I need to find what I need to add here to complete the square. To do that, you take the coefficient of x, in this case it's minus 1, you divide it by 2, and then you square it, and you get 1/4. So I need to add 1/4, and at the same time I'm going to subtract 1/4 so I don't change my original equation here. I can complete the square among these three terms. This is not only is factorable, also I get the same binomial if I factor them, and I get x minus 1/2 times x minus 1/2, which is the same as x minus 1/2 square. I completed square here already. This 2 belongs to each term inside this parentheses. I need to move that minus 1/4 outside this parentheses. Then I'm going to multiply it with this 2. Then I would get 2 times x minus 1/2 square. Here I multiply 2 by 1/4 and move it outside the parentheses. That becomes minus 2 over 4 minus 24. I'm getting really close to this form here. So this would be 1/2. You're going to combine that with minus 24. The LCD is 2. So I have 2 times x minus 1/2 square. If I combine these two terms together, I get 1 minus 48, but here's minus 1 minus 48 over 2, so I get minus 49 over 2. So now I have this format. My h is equal to 1/2 and my k is minus 49 over 2, and that is the position of my vertex. 1/2 minus 49 over 2. For part B, we want to find the intercepts. To find the intercepts, if I let x be equal to 0, I can solve for y. If I plug into the original equation, then we get minus 24. This is where my graph going to intercept y-axis. This is my y-intercept. To find the x-intercept, you let y be equal to 0 and solve for x, or in this case
your g of x is equal to 0. So 0 is equal to 2x squared minus 2x minus 24. Here I can factor the 2. If I want to solve for x, I would have to factor x squared minus x minus 12, and this is factorable. Here I get x and x. You get 3 and 4. You want to get minus 1 out of that, would be minus 4 plus 3 equal to 0. So x plus 3 is equal to 0, means x is equal to minus 3, or x minus 4 is equal to 0, so x is equal to 4. So your x intercepts are 4 and 0, and negative 3 and 0. So far we have g of x in standard form, and we find the x and y intercepts. If I graph the line, I see my vertex is at point 1/2 and minus 49 over 2, and my y-intercept would be at the point 0 and minus 24, and my x and my x-intercepts are at point 4 and minus 3. Find its maximum and minimum value. This problem opens upward, so we only have a minimum value at the vertex, which would be 1/2 and minus 49 over 2. The axis of symmetry would be the line going through the vertex. So in this case, you can see x is equal to 1/2. So the axis of symmetry is a line passing through the vertex, and that would be x is equal to 1/2. And that would be the sketch of the graph.
Here it's given to us the vertex being -2 and -3, and we know my graph going to passes through this point 0 and minus 19. They want us to write down the equation, the polynomial, in the standard form, but we also know the p of x can be written as a times x minus h squared plus k. I'm going to use this one here and write p of x is equal to some constant a times x minus h squared plus k. I'm going to start with this. Since the vertex is given to me as -2 and -3, so my h is equal to -2 and my k is equal to -3. So I can substitute those values now in here. So this would be equal to a times x minus -2, your h is -2 squared, plus your k is -3. So what I have here is a times x plus 2 squared minus 3. In order to solve for a, I need to use this point was given to me. They're saying that if x is equal to 0, y is equal to -19. That's what it means. When x is equal to 0, y is equal to, or p of x equal to -19. That's how you can solve for a. So if p of x is equal to -19, they're telling us that x is equal to 0. So I'm going to substitute 0 here and just simply solve for a. So I get -19 equal to, this would be 0 plus 2 would be equal to just 2. 2 squared would be 4. So I get 4a minus 3. If I add if I add 3 to both sides of the equation, if I add 3 to both sides of the equation, I get minus 19 plus 3 in the left-hand side, which would be minus 16 equal to 4a. Divide both sides by 4. Now I would get a is equal to negative 4. Okay, so now I got my equation. So let's write down our equation. P of x then must be equal to, now I know my a is equal to minus 4. That would be minus 4 times x plus 2 squared minus 3. But they want us to write this in standard form. So I need to expand this, would be minus 4 times, that would be x squared, that would be plus 2ab, that would be plus 4x plus 4 minus 3. If I go ahead and distribute this with minus 4x squared minus 16x minus 16 minus 3. So my P of x in the standard form then would be equal to minus 4x squared minus 16x minus 19. That is my P of x in the form that they want us to write: ax squared plus bx plus c. Here we're going to solve x squared plus 6x greater or equal to minus 8. So let's go ahead and move everything to one side of the equation. I get x squared plus 6x. If I add 8 to both sides of the equation, I get plus 8 greater or equal to 0. That's what you want to do. You want to let your expression to be greater or less than or equal to 0, and then you look for the zeros. You can factor this. If it's factorable, we factor them. Here would be x and x. So for 8, I'm going to put 2 and 4. That adds up to 6. Both are positives. So I can easily find my zeros here. So on the x-axis, I know my zeros are minus 2. So if I were to solve this for x, x plus 2 equal to 0, so x equal to minus 2 would be one of my zeros here, right there. And x plus 4 equal to 0, x will equal to minus 4. Somewhere around here is minus 4. So as you can see, when you have two zeros, you create 3 regions. Okay, one region would be between minus 4 and negative 2. The other region would be to the right of negative 2. The other region would be to the left of negative 4. The solution usually alters between these regions. What we need to do is to get a test point to see which one of these regions are solution. The easy one to check probably would be 0, right? If I substitute for each x0, see what happens. The first parenthesis would become 0 plus 2, which is some positive number. We don't care about the value of that, really sign we're concerned. The second parenthesis, 0 plus 4 would be plus 4, that would be also positive. So the product would be positive. Is that what you want? it says you want it to be greater or equal to 0. Yes, I want that to be positive. So because 0 checked out, any point within this region would be the solution. So if I were going to write this in interval notation, I would put brackets because -2 is also included. It's equal to would be all the numbers from -2 to infinity would be my solutions. Now, because the solution alters, I could guess the other solution must be right there. But let's pick a point here, -5. If I pick -5 as my test point, -5 would cause the first parentheses become minus some number. -5 would cause the second parenthesis becomes negative. The product would be positive. That's exactly what you want. So your other solution would be all or union, all the number from -infinity to -4 would be the other solutions. You do not want to include any points between -4 and -2. If this were less than 0, then you would pick all the points between -4 and -2 as a solution. The farmer has 80 feet of fence to enclose a rectangular garden. Maximize the area enclosed. So this corresponds to the parameters P. And for the rectangle, you know that the formula, if this is length and this is width, so the P is equal to 2 times length plus 2 times width, or 2 times length plus width. So we know P is equal to 80. So if I put in this formula, then I can reduce this, divide both sides by 2. Then I would get 40 is equal to length plus width. If I solve length in terms of the width, so length would be 40 minus W. Now we want to maximize the area. Area is equal to length times width. I already find length in terms of width. I'm going to substitute for each L 40 minus W times W. So here I get 40W minus W squared. So this would be equal to minus W squared. I'm going to write in standard form, plus 40W. Now to maximize this, we really want to find, this is a parabola that opens upward or downward. The coefficient of W squared is minus, right? So the parabola opens downward. So the maximum point would be the vertex. How do you find the x position of the vertex? We have x equal to minus b over 2a. What is b in this case? Your b is the coefficient of w, which is 40. Your a is minus 1. So minus 40 over minus 2, that give you 20. So x position of the vertex is 20. This is where you would have your graph would be maximized. So in this case, the W would be equal to 20. The length would be 40 minus 20, which is equal to also 20. So the area would be maximized when the length and width would be equal to 20. 20 times 20, which is equal to 400. 400, this is area, the unit would be square feet. 400 square feet says maximize the area enclosed would be 400 square feet.
Here we want to sketch and justify the graph of f of x. Here if I expand this, I get x to the power of 2 and then I have times x. So this is the third order polynomial where n, the exponent is 3. If I expand this, we don't really have to multiply these two, come up with this conclusion. You see you have x squared times x, that give me x to the power of 3. So if I expand this, I get actually if I do that, I get x cubed. You can go ahead and multiply, expand x plus 4, multiply x plus 4 times x plus 4, and then multiply by x minus 1. If you do this correctly, you get x cubed plus 7x squared plus 8x minus 16. But we don't really have to do that to conclude that this n is 3. Just by looking at this, we can come up with that conclusion. And as you can see, the leading coefficient is positive. So you're looking at the third order polynomial with the leading coefficient is positive, and we know the end behavior of that. From the left it should go down, and from the right it should go up, like y is equal to x cubed. If you remember the graph of that, the graph would go to the, from the left go down, and from the right go up. So let's take a look at the zeros here. We have x plus 4 equal to 0, so x equal to minus 4. So one of the zeros that I have is x equal to minus 4, and the other one is x minus 1 equal to 0, x equal to 1. For x is equal to 1, the exponent here is 1, so it means your graph gonna cross this point, and we know the end point going up, so this is how your graph should behave. If you let x equal to 0, we can easily find the y-intercept. That would be 4 squared times minus 1, so they give me minus 16. So my graph gonna pass us through this point here. So far I know that my graph gonna pass us through this point here and also cross 1, so it would be somewhat like that. Okay, and at x equal to minus 4 we have multiplicity of 2, so it means from the left side I know the graph gonna go down this way, and because the multiplicity is 2, then it's gonna bounce back here, so it's gonna be tangent to this point and go down. So from here on we're just gonna kind of guess it is somewhat like that. So that would be the graph of this polynomial. You may want to make this a little bit better. That would be somewhat like that. If you go then graph this using your calculator, you should see this shape on your calculator. Here you want to sketch f of x equal to x plus 3 times x plus 1 squared times x minus 1. If you look at this, we have x to the power of 1 times x to the power of 2 times x to the power of 1. So if you multiply these, you would get x to the power of 4. So this is the fourth order polynomial with the leading coefficient being positive. So end behavior from the left go up, from right also should go up. At x minus 1 as being one factor, one root would be x is equal to 1. So the multiplicity of this is 1, so it means my graph should cross this point and go up. I can find the y-intercept. If x equal to 0, you can see you get 3 times 1 times -1, so that would be -3. So my graph gonna pass us through point -3 on y-axis, so this is gonna be going up like that. At x equal to -1, we have the multiplicity of 2, so it means that it's gonna be tangent to this point. It's not gonna cross that, so it's gonna go up somewhat like this. And at x is equal to -3, the multiplicity is 1, so at this point it's gonna cross, and we know endpoints are going up, so it's gonna bounce back somewhat like this at this point. So the shape of your graph would look like that. You can confirm this by using your graphing calculator. Find a polynomial with integer coefficients that satisfy the given condition. You have f of x has degree 5 zeros, 4 minus 2 and 1 plus 2i. The leading coefficient is -3. The 0 minus 2 has multiplicity of 2. So if 4 is one of the 0, then one of the factor must be x minus 4. If I solve this for x, I get x equal to 4 as being one of my 0. If -2 is another 0, the factor would be x plus 2, and here it says the multiplicity of 2 for the 0 of -2, so I need to square this. It says the leading coefficient is -3, so I'm going to put -3 here. And it says that my other 0 is 1 plus 2i. So one factor would be x minus 1 plus 2i, and the other factor would be its conjugate, would be x minus 1 plus 2i. So this would be x minus 1 plus 2i, and this would be x minus 1 minus 2i. I write it this way so I can use the difference of square. This would be first term square minus the second term square. It would be a lot easier for me to multiply these. Well, here would be x plus 2ab would be 4x plus 4, and my f of x would be then -3 times x minus 4 times x plus 4 times this would be x square minus 2x plus 1, and here would be 4i squared is minus 1, and that would make this plus 1. So we have x squared minus 2x plus 5 times, here we have a square here, we missed that earlier. That would be x squared plus 4x plus 4 times x minus 4 times minus 3. Alright. Here if I multiply these last two terms, term by term, I would get so we get x to the power of 4 minus 2x to the power of 3 plus 5 x to the power of 2 plus 4x to the power of 3 minus 8 x to the power of 2 plus 20x. I'm going to continue down here, plus 4x squared minus 8x plus 20. Okay, that would be the product of these two polynomials. And you can combine like terms here. You get x to the power of 4 plus 2x cubed plus x to the power of 2 plus 12x plus 20. Then we need to multiply that by x minus 4 and then multiply by minus 3. You can multiply this any order you like. So I'm going to go ahead and multiply this binomial by the last polynomial here. So that would be x to the power of 5 plus 2x to the power of 4 plus x to the power of 3 plus 12 x to the power of 2 plus 20 x minus 4 x to the power of 4 minus 8 x to the power of 3. I'm going to continue the rest down here, minus 4x squared minus 48x minus 80. Now I need to combine like terms and go to the new page. You get minus 3 times x to the power of 5 minus 2x to the power of 4 minus 7x to the power of 3 plus 8x to the power of 2 minus 28x minus 80. And if I multiply negative 3, you get negative 3x to the power of 5 plus 6x to the power of 4 plus 21x to the power of 3 minus 24x to the power of 2 plus 84x plus 240. So this is my polynomial. Find all the zeros for this polynomial. If we know 1 is a 0, so if 1 is a 0, x equal to 1, the factor would be x minus 1. So if I divide x minus 1 into this polynomial, the remainder should be equal to 0. I can use a long division by quoting the coefficient of this polynomial would be 1 for x cubed and negative 5 here for x squared, 17 for x and negative 13. Then this number here would be 1. Bring the 1 down, go through the steps for synthetic division. Negative 5 plus 1 would be negative 4. And follow the steps. Here you would get 1 times negative 4 would be negative 4. 17 minus 4, you add them up, you get 13. And then we follow the same steps again. 1 times 13 is 13. As you can see, the remainder is equal to 0. So the quotient would be x to the power of 2, its coefficient is 1, minus 4x plus 13. So this would be my other factor, another factor there. So one factor is x minus 1 for this polynomial, and the other factor is x squared minus 4x plus 13. Now, this doesn't look like is factorable, so I can use the quadratic formula. X would be equal to minus b, so it would be 4 plus and minus b squared, which is 16 minus 4a is 1, c is 13, divided by 2a, which is 2 here. So you would get 4 plus and minus, here you get 16 minus 4 times 13, that give you negative under the radical, would be negative 36 over 2. So x would be equal to 4 plus and minus 6i divided by 2. If I divide each term by 2 here, I would get, or you can factor the 2 at the top, however you want to look at this. We can reduce to 2. So x would be equal to 2 plus and minus 3i. So the factors, or all the zeros that we have here, would be 2 minus 3i, 2 plus 3i, and we knew that one of the zeros, x minus 1, was the other factor, so the other zero would be 1. So these are all the zeros of this polynomial. Given this polynomial, we're going to find all possible rational zeros. For that, we're going to list p and q. We look at the constant 12 and write all the factors of 12. That would be for p. So it would be 1, 2, 3, 4, 6, and 12. This would be all the factors of 12. And for q, you would look at a and write all the factors of that would be 1 and 2. So all possible rational zeros would be all the combinations of p over q. So in this case would be plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. Prove that 3 is an upper bound. So let's see. If I go ahead and use the long division, and if divide that into this polynomial, I'm going to go ahead and write down the coefficients here. It would be 2, negative 3, negative 8, 12. So if I go ahead and bring the 2 down and follow the steps for the synthetic division, I get minus 6 here. So it would be minus 9 multiply negative 3 by minus 9 and place it up here. you would get 27. Add that to -8. I give you 19. Okay, again multiply -3 by 19. You would get -57, and here you get -45. So as you can see, the signs alters from between plus, minus. So that would be the lower bound, since the sign alters there. And here's this proof that -3 is a lower bound. We just did that. That was actually part C. Prove that 3 is the upper bound. So we do the same thing with +3 here. So it'd be 2, -3, -8, 12, same thing. Bring down the 2. So you get 6. So we add them up, you get 3. Then here we have 9, you get 1. And then finally you get 3 here, and then you get 15. You notice that all the signs are positive, all positive. And that was indication of that is the upper bound. Okay, so that was for part B actually. How many positive, negative, and imaginary roots can the equation have? So for the positive would be for the positive would be 2 or 0. And we can find out by looking at the change of sign here. The polynomial sign goes from plus to minus. That would be 1, that the sign alters. And then here we have minus to minus, it doesn't change, but here it changes again. That's the second change. So the positive would be either 0 or 2. So it either would be 2 or 2 minus 2, which is 0. So we can record it as 0 or 2. For the negative, we need to find f of minus x. That would be the same as 2 times minus x cubed minus 3 times minus x squared minus 8 times minus x plus 12. So this would be equal to minus 2x to the power of 3 minus 3x to the power of 2 plus 8x plus 12. So now we're going to see the change of sign would be from negative and negative, not changing. Here's where the sign changes from negative to positive, and that's the only time, one time. So for the negative, then would be 1. We cannot go below that, so that would be just 1. And for the imaginary, so if it's positive number is 0, negative is 1, so the total should be 3 because that's a third order. So this must be 2 then, for this case. If you have 0 positive, 1 negative, the rest should be for the imaginary, which is 2. If you have 2 positive and 1 negative, that's a total of 3 already, so it would be 0 imaginary there. Given this equation, we want to find all possible rational zeros. We're going to look at the constant 1 here. That's my p. All the factors of that would be 1. And then you look at the leading coefficient of polynomial q. That is 2. So all the factor of that would be 1 and 2. So find all possible rational zeros would be all the p over q's, which would be plus and minus 1, plus and minus 1/2. You want to know how many positive, negative, and imaginary roots can the equation have. For that, we're going to see how many times the signs alters between plus and 1. That would be 1 time. Then we have from minus to plus, that would be another time, second time, and then that's it. So we have 2 times that sign alters there. So we would have, for positive roots, we either have 2 or 0. 2 minus 2 would be 0. For the negative, you need to calculate f of minus x, which is 2 times minus x to the power of 4 minus 5 times minus x to the power of 3. I'm going to continue down here, plus 3 times minus x plus 1. So this would be 2x to the power of 4 plus 5x to the power of 3 minus 3x plus 1. So the number of times the signs alters here from plus to plus, it's not changing. Here would be 1 time, and looks like this would be another time, 2 times. So for the negative, so would be either 2 or 0 again, 2 or 0. And for the imaginary, then we have a total of 4 zeros. So when we have 2 positive and 2 negative, then we would have 0 imaginary here. If I have 0 positive and 0 negative, then I would have 4 imaginary here. The other possibilities would be if you have 0 positive and 2 negative, then you would have 2 imaginaries. If I have 2 positive and 0 negative, then we have 2 imaginary.